Let's talk about analyzing owl population growth with matrices. Northern spotted owls live in the Pacific Northwest, primarily in old growth forests. So we're talking about southern British Columbia, western Washington, western Oregon, and northern California. In the 1990s, the lumber industry wanted to cut down trees in the owl's habitat. Environmentalists were concerned about the decreased size of the habitat. We can analyze the growth of the northern spotted owl population using matrices. This example and these data come from David Lay's book, Linear Algebra and Its Applications. I'm showing you an ancient edition of the book because my wife and I collect books signed by the author, and I actually had him sign this book. He was a friend. I knew him from a professional group, the Association of Christians in the Mathematical Sciences. He's a great guy. He passed away a few years ago. Here are the life stages of northern spotted owls. Juveniles are up to 1 year old, very cute guys. Subadults are 1 to 2 years old, and adults are 2 years old or older. We assume that there's a 1-to-1 ratio of females to males, so we count just the females in this model. On average, in a given year, an adult female will give birth to 0.33 juvenile female per year. In other words, once every 3 years, an adult female will give birth to a juvenile female. On average, in a given year, 18% of the juveniles will survive to become subadults, 74% of the subadults will survive to become adults, and 94% of the adults will survive. We can represent this information using a matrix. Let J of k equal the number of female juvenile owls, S of k equal the number of female subadult owls, and A of k equal the number of female adult owls in year k. Then from the information we saw earlier, we have this vector, J of k plus 1, S of k plus 1, A of k plus 1 equals this matrix times J of k, S of k, A of k. Why is that? Okay, notice, J of k plus 1 is going to equal this times this, equals the dot product of those two. So it's going to equal 0 times J of k, 0 times S of k, plus 0.33 A of k. In other words, the number of juveniles you have in year k plus 1 is going to be 0.33 times the number of adults you had in the previous year, year k. That's because, as we saw earlier, each adult female produces 0.33 juvenile females. Similarly, subadults in year k plus 1 is going to equal 0.18 J of k. So only 18% of the juveniles survive to become subadults the next year. And we also have this equals this times this. In other words, A of k plus 1 is 0.1 S of k plus 0.94 A of k. That's because the number of adults you have next year is 71% of the subadults that survive to become adults and 94% of the previous year's adults. If this model holds true, what happens to the northern spotted owl population over time? Okay, again, this is what happens in year 1. So we start with this in year 0, whatever these numbers are, this is what we have in year 1. In year 2, we would just have this matrix times what we had in year 1. But we can rewrite this, okay? Because we know, based on a previous slide, that this is our matrix times J of 0, S of 0, A of 0. So in other words, we can represent this as the matrix squared times J of 0, S of 0, A of 0, that vector. In general, J of k, S of k, A of k is going to equal this matrix raised to the k times J of 0, S of 0, A of 0. In other words, if we were going to raise it to the 10, this is what we end up with. So after 10 years. After 100 years, this is what we get. Doesn't look good. So in other words, the number of adults in year 100 is going to look like this. Not too many adults in year 100. And then if you extrapolate out to 1,000, this is what you'd end up with. It would just be the 0 matrix times what you started with originally. In other words, the number of adults you have in year 1,000 is 0. Now, it's dangerous to extrapolate out so far because trends change over 1,000 years, but it doesn't bode well for the owl, the northern spotted owl. The population dies out. The critical factor is this. Okay, only 18% of the juveniles survive to become subadults. That's because one reason is, there are various reasons, but one reason is it's difficult for them to find new habitats to establish their own domain. On average, in a given year, 18% of the juveniles will survive to become subadults. How much bigger does this percentage have to be in order for the population to survive? We're just going to try guess and check. Try 23%. So replace the 18 with 23%, and this is what we end up with. Yeah, this is not looking too good. So the population is still dying out. Not so great. Let's try 26% instead of 18% or 23%. Actually, this works out pretty well. So raise that matrix to 1,000. This is what we end up with. In other words, the number of adults you have in year 1,000 is 0.372 times the number of juveniles in year 0, plus 1.433 times the number of subadults in year 0, plus roughly twice the number of adults you had in year 0. So the population is growing. So it looks like 26% is what you need. You need, basically you need it to be 26%. What prevents juveniles from becoming subadults? Habitat loss due to wildfires, also due to timber harvesting, the logging industry. They love those old growth forests. And barred owls, another owl that's competition for the northern spotted owl. So spotted owls are smaller and less aggressive than barred owls. They're aggressive and larger cousin. So there are different proposals of dealing with this. Recently, the U.S. Fish and Wildlife Service has proposed killing 500,000 barred owls to help spare the spotted owl. It's a controversial issue, killing off 500,000 owls to save another owl, to say the least.